Hi, I'm Sean Gannon, and this is MinuteMath. And today we're going to solve this system of equations by elimination.
Minute Math. When you need help, you use Minute Math.
So we're given the problem negative 4x minus 2y equals negative 12, and 4x plus 8y equals a negative 24. And we're solving this by elimination. So elimination here, what I'm going to do is going to add these two equations to each other to eliminate a variable. So by doing that here, I can add down. We have minus 4x plus 4x that eliminates the x's, giving us 0x, right? Which we don't really need to write. Negative 2y plus an 8y is a positive 6y, and negative 12 plus a negative 24 is a negative 36. All right, now we solve for y. Divide both sides by 6 here, and we get y equals a negative 36 divided by 6 is a negative 6. So our y value is negative 6, and we need to now find the x value. So we take a look at our original equations, and we pick one of them to substitute y in negative 6 in for y. So let's go with the first one. Negative 4x minus 2y, and y being negative 6 here, equals a negative 12. All right. So negative 4x here, negative 2 times negative 6 is a positive 12, right? Two negatives make a positive, and that equals a negative 12. Subtract 12 to both sides. We're left with a negative 4x equals a negative 12 minus 12 is negative 24. Divide both sides by a negative 4. And what are we left with? Well, x equals negative divided by negative is a positive. 24 divided by 4 is 6. So we have x is 6, y is negative 6. Our final answer is a coordinate point 6, comma, negative 6. And there we have it. Right. So we're given 4x plus 8y equals 20, and negative 4x plus 2y equals negative 30. And we want to solve this system by elimination. So first step here is I'm going to add the two equations to each other. This will eliminate 4x plus a negative 4x, eliminates the x values, 0x, which we don't really need to write. All right, 8y plus 2y is 10y, equals 20 plus a negative 30 is a negative 10. Divide both sides by 10, and this one's fairly easy so far. Y equals negative 10 divided by 10, negative 1. All right, so we have our y value. We need to find our x value. At this point, we can pick either one of our equations to solve for x. Okay, let's go with, why not, the first one here. Let's do that here. So I take the first equation, 4x plus 8, and instead of y, I'm going to substitute negative 1. And we have equal 20. Now I'm solving for x. 4x here equals 8 times negative 1, which is a minus 8. We have 20. Add 8 to both sides, and we're left with 4x here equals 20 plus 8, which is 28. From there, we divide both sides by 4, and we're left with x by itself here, and 28 divided by 4 is 7. So now we have our x and y value. We can write this as a coordinate point as 7, comma, negative 1. And here is the solution for solving these two equations by solve the system by elimination. There we go. So we're given x minus y equals 11, and 2x plus y equals 19. And we got to solve this by elimination. Well, what I want to do is add these two equations to each other. I recognize a negative y here and a positive y, so when I add them together, the y's will cancel out, giving us, well, a 0y, which we don't really need. X plus 2x is a 3x right here, and then 11 plus 19 gives us a good old 30. So we have 3x equals 30 here. Divide both sides by 3, and fairly easily, 30 divided by 3 is 10. We already have our x value. All right, so now we need to take that x value and plug it into one of our equations to solve for y. I always like to pick the easier one, and from my perspective here, let's say the second one is actually easier. We have 2x, x being 10 here, plus y equals 19. 2 times 10 is 20, plus y equals 19. Subtract 20 to both sides, And this is a fairly easy problem again. Y is by itself. 19 minus 20 is a negative 1. So we have y equals negative 1, x is positive 10. We can write that as a coordinate point here, 10, negative 1. And now we know how to solve this system by elimination. So we're given negative 6x plus 5y equals 1, and 6x plus 4y equals negative 10. And we're solving this again by elimination. To do that, we then identify something that we can add together that will eliminate the variable. Here I see is x. If I add these two equations together, the x variables will cancel. Negative 6x plus 6x is 0x. Don't need to write that. 5y plus 4y now is a positive 9y. And 1 plus a negative 10, negative 9. Divide both sides by 9 here. And we get halfway there. Y is by itself. Negative 9 divided by 9 is a negative 1. So we take that information and we have to plug that back into one of our equations and solve for x. I like to pick the easier one of the two, and I think that's the second equation. We take 6x here plus 4, and instead of y, I'm going to put negative 1 in. And it's equal to negative 10. 4 times negative 1, well, you should know that. That's a negative 4. Add both sides, add 4 to both sides, get us one step closer to x by itself. We have 6x here by itself, and negative 10 plus 4 is a negative 6. Divide both sides by 6, and we're all pretty much there. Negative 6 divided by 6 is a negative 1. We have negative 1 for the x and y value. We can write that as a coordinate point, negative 1, and there we have our answer, negative 1, comma, negative 1. So we're going to solve this system by elimination. We're given negative 2x minus 9y equals negative 25. Negative 4x minus 9y equals a negative 23. Normally I would just add these two equations and we're almost there. We would see 9s are a good choice here to eliminate. But if I add the two together, we won't eliminate the y value. So what I'm going to do is actually take the second equation and I'm going to multiply that by a negative 1. Now you can subtract the two equations, that's fine. I like to do it this way. So rewrite this, negative 2x minus 9y equals a negative 25. Multiply negative 1 to all parts here. Don't forget any parts. Negative 1 times negative 4x, positive 4x. Negative 1 times a negative 9y is a positive 9y. Negative 1 times a negative 23 is a positive 23. All right, now I can add my two equations to eliminate the y variable. Negative 2x plus 4x is a positive 2x. Negative 9y plus 9y is 0y. Don't really need to write that. Equals here, negative 25 plus 23 is a negative 2. I now divide both sides by 2 here, and we're left with x by itself, which is a negative 1. So, with that information here, we need to move on and solve for y. I pick one of my equations here to use to plug negative 1 in for x, and I try to find the easier of the two. This one's kind of hard. Let's just pick the first one. Negative 2 here, and I plug negative 1 in for x, and we minus 9y equals a negative 25. Okay. Well, solve for y. Negative 2 times negative 1, positive 2. Minus 9y equals a negative 25. Subtract 2 to both sides, negative 9y equals, well, negative 25 minus this 2 is a minus 27. Divide both sides by negative 9, and negative 27 divided by negative 9, two negatives make a positive, y becomes a positive 3. So we're left with the coordinate point now, negative 1 comma positive 3, as our solution when solving this by elimination. So we're given 8x plus y equals negative 16, and negative 3x plus y equals negative 5. And we want to solve this by elimination. I like to add my two equations here. Well, if I add them right now, nothing gets eliminated. Closest thing I can see is y and y right there. So if I can make that a negative y, I add them together, it will eliminate the y variable. So I'm going to take my second equation and multiply it all by a negative 1. What does that give us here? Numerator, or not numerator, the top equation, 8x plus y equals negative 16 stays the same. The second equation, not the denominator, it's not a fraction. We multiply by negative 1 to all parts. Negative 1 times negative 3x, positive 3x. Negative 1 times y, a minus y. Negative 1 times a negative 5, positive 5. Now we can add our two equations. 8x plus 3x gives us a 11x. Y plus a negative y is 0. They are eliminated, hence the term. Negative 16 plus 5 is a negative 11. Alright, now we need to solve for x. Divide both sides by 11, because opposite of multiplication is division. X is by itself on the left-hand side. Negative 11 divided by positive 11, negative 1. Halfway there, we need to take that value here and plug into one of our original equations to solve for y. Pick the easier one. I think it's the second equation. So we take negative 3x, and instead of x, we put in a negative 1. Plus y equals a negative 5. Alright, now what we need to do, negative 3 times a negative 1 is a positive 3. Positive 3 here. Y equals a negative 5. From there, we subtract 3 to both sides, and we're already there. Y equals negative 5 minus 3 is a negative 8. And we have our x and y value here. We can write that as a coordinate point as negative 1 comma negative 8. And there is our solution. So we're given this problem, negative 6x plus 6y equals 6. And we need to solve, and negative 6x plus 3y equals negative 12. And we're solving by elimination. The goal of elimination is to eliminate a variable. I see here the negative 6x and negative 6x is my target. We have ability here very close to eliminate them, but I can't just add it together, and I like to add for elimination. So what am I going to do? I'm going to take the second equation and multiply it by a negative 1 right there. In doing so, the top equation stays the same. Negative 6x plus 6y equals positive 6. The second equation, multiply negative 1 to all parts. Negative 1 times negative 6 is a positive 6x. Negative 1 times 3y is a minus 3y. And negative 1 times a negative 12 is a positive 12. Two negatives make a positive with multiplication. So now we're going to add the two equations, and as you can see, our goal will be revealed. Negative 6x plus 6x is 0x, so they're eliminated, hence the term. 6y minus 3y is a positive 3y. 6 plus 12 is 18. We take 3y and we divide both sides by 3, gives us y by itself, and 18 divided by 3 is a good old 6. Alright, halfway there. We need to take that value for 6 and plug it into one of our equations here and solve for x. We try to see which one was easier, and I think it's the top one. Negative 6x here plus 6y, but instead of y, I'm putting that 6 in. A lot of 6's here. Oof. Be careful with that. Alright, we're equal 6. So, 6 times 6 is 36. Bring down the other stuff. Subtract both sides by 36. And we're left with negative 6x by itself here. 6 minus 36 is a negative 30. Divide both sides by negative 6, and we're left with x equals negative 30 divided by negative 6. Negative divided by negative is a positive, and 30 divided by 6 is 5. So we have 5 right there for x. To write this as a coordinate point, x is 5, y is 6, and there we have our answer, 5, 6. And we're going to solve this problem here. 7x plus 2y equals 24. 8x plus 2y equals 30. Okay. Well, right now with elimination, I try to eliminate one variable by adding the two equations. Closest thing I can see is 2y right here. But I can't just add the two together. I'm going to take the second equation and multiply it by a negative 1. So, rewrite this equation. The top equation, 7x plus 2y equals 24. In the second equation, distribute the minus 1 to all parts. Negative 1 times 8x, negative 8x. Negative 1 times 2y is a minus 2y. And negative 1 times 30 is a minus 30. Alright, so now we're going to add the two equations, and our goal will be revealed. 7x minus or plus a negative 8x is a minus 1x. 2y minus plus a negative 2y is just 0. The y's are eliminated. Got it. 24 minus 30 is a minus 6. Okay. Divide both sides by negative 1. And let's get x by itself here. Negative 6 divided by negative 1, positive 6. All right. So we got x equals 6, and we need to plug it into one of our other equations to solve for y. Let's go with the top one. 7 times 6, right here, 6 in for x, plus 2y equals 24. 7 times 6, 42, plus 2y equals 24. Subtract 42 to both sides. 2y is right here, and 24 minus 42 is a negative 18. We now divide both sides by 2 here to get y by itself, and y equals negative 18 divided by 2, which is a negative 9. So we have our x and y value. Let's put it as a coordinate point, 6 comma negative 9, and there we have our final answer, 6 comma negative 9. So we're given this problem, 5x plus y equals 9, 10x minus 7y equals a negative 18. Well, what I want to do is, the goal is to add these two equations here to see if a variable eliminates. But nothing I can do right away does that. But I see 5x and 10x, they're pretty close. 5 multiplied by 2 is 10, we're on our way there. So I'm going to take this numerator and I'll multiply it by a negative 2. And what that's going to do is make the numerator, not the numerator, the top equation, it's not a fraction, I always say stuff like that, sorry. Negative 2 times 5x is a negative 10x. Negative 2 times y is a negative 2y. Negative 2 times 9 is a negative 18. Second equation just comes over, 10x minus 7y equals a negative 18. And now what we can do is add these two equations together to eliminate the variable x here. Negative 10x plus 10x is just 0x. Don't need to write that. Negative 2y plus a negative 7y, negative 9y. Negative 18 plus a negative 18 is a negative 36. Divide both sides by negative 9 to get y by itself. Negative 36 divided by negative 9, two negatives make a positive, so 36 divided by 9 is 4. We have our y value here, we need to find our x value. So we gotta plug it back into one of our original equations. That's the easiest, and I think it's the first one. Well, it can be either one, but I pick the easier ones. 5x here, plus, instead of y, I'm putting a 4 in, equals 9. Solve for x, subtract 4 to both sides. 5x here equals 9 minus 4, which is a 5. Divide both sides by 5, and we're pretty much there. 5 divided by 5 is 1. So we have the coordinate point, 1 comma 4, and that is our final answer. We're given this problem, negative 4x plus 9y equals 9, x minus 3y equals negative 6, and we have to solve this by elimination. So my goal here is to take one of these equations and I'm going to multiply it by a factor or some number, right, to see if we can eliminate a variable. My goal is y here. I have 9y and minus 3y. 3 can get into 9 pretty easily. So we multiply both sides by a minus 3 here. The top equation stays the same, 4x, minus 4x, sorry, plus 9y equals 9. Second equation, now we distribute the minus 3, minus 3x. Minus 3 times a minus 3y is a oof, why did I do that? It shouldn't be a minus 3. Catching myself right here. Let's go with a positive 3. You'll see why in a second. Multiply 3 times x is 3x. 3 times a negative 3y is a minus 9y. 3 times a minus 6 is a minus 18. Got ahead of myself. And the reason why I did that is I wanted this to be a negative because I prefer to add the two equations. Okay? If I had multiplied a negative 3, it would have been a positive 9y, and I'd have to subtract the 2. Makes it more difficult, in my opinion. Minus 4x plus 3x, let's add them together, is a minus 1x. 9y plus a negative 9y is 0y. Don't need to write that. 9 plus a negative 18 is a negative 9. Divide both sides by a negative 1 here, and we're left with x by itself. Negative 9 divided by negative 1 is a positive 9. So we have our x value, we need to find the y value. So what I'm going to do is I pick one of my equations and substitute x in, or 9 in for x. I try to find the easier one. I'm thinking maybe the second equation. So instead of x, I'm putting a 9 minus 3y here equals negative 6, and I'm solving for y. Subtract 9 to both sides, and we have negative 3y equals negative 6 divided by minus 9, or sorry, negative 6 minus 9, negative 15. Divide both sides by negative 3 here, and y is equal to negative 15 divided by negative 3, positive 5. So we have y is 5, x is 9. We can write that as a coordinate point, 9, 5, and that is our answer. We're given this problem, negative 3x plus 7y equals a negative 16, negative 9x plus 5y equals 16, and we have to solve this by elimination. So what am I going to do here? Well, I see the negative 9x and the negative 3x. They're pretty close. If I multiply the top part by a positive 3, we'd have 9x and negative 9x, add them up, they eliminate each other. So we're going to take the top equation and multiply it by a positive 3. What do we get? 3 times negative 3x, multiply it by a negative 3. I always do that. We want a positive 9x there. Negative 3 times negative 3x, positive 9x. Negative 3 times 7y is a minus 21y. And negative 3 times a minus 16 is a, what is that? 48? Is that right? 48? Yeah. Negative 3 times 16. Negative 16 equals a positive 48. Let's double check that really quickly, see if it's right. Yep. I had it saved there. Alright. So, move this second part over. Negative 9x plus 5y equals 16. Negative 9x plus, 9x plus negative 9x. We're going to add them together. That was our goal. Eliminate them. Negative 21y plus a 5y here. Oh, what does that come out to be? That is a negative 16y equals 48 plus 16 right there. What is that? 2, 8, 2, 4. Carry the 1, 5, 6, 64. Alright, so now we want to divide both sides by negative 16 here. We're left with y by itself, and 64 divided by negative 16 is a negative 4. So we have our y value, we need to find our x value. So what are we going to do? We're going to go plug it into one of our equations and solve for x. Find what you think is the easier one. I think it's the second one. Negative 9x plus 5 times a negative 4 equals 16. Negative 9x here plus 5 times negative 4 is a negative 20 equals 16. Add 20 to both sides, and we're left with negative 9x equals 16 plus 20, which is 36. Divide both sides by negative 9, and we have x by itself here, and that's a negative 4 as well. So our coordinate point here is negative 4 comma negative 4, and that's how you would, or a coordinate point, our solution. Well, it could be a coordinate point if you graphed it. And there we have it. We're given this problem, negative 7x plus y equals negative 19. Negative 2x plus 3y equals a negative 19. And we need to solve this one by elimination. So right now, I cannot add these two equations, and some variable gets eliminated. I need to adapt it. I noticed this y and 3y is probably my best bet. If I multiply the top equation by a negative 3, negative 3 times y is negative 3y. We add the 2, and we get the variable eliminated. Negative 3y and 3y cancel out. So let's do that. Negative 3 times a negative 7x is a positive 21x. Negative 3 times a positive y is a minus 3y. And negative 3 times a negative 19 is a positive 57. Alright. Second one stays the same. Minus 2x here plus 3x equals a negative 19. We're now going to add these two equations together. 21x minus 2x is a minus 19x. Minus 3y and, 3, this is a y here, excuse me. Be careful there, that's a y, double check the stuff. Whoops. Minus 3y and 3y, eliminate, nothing there. 57 minus 19 is a 38. Yeah. So now what we want to do is divide both sides by negative 19. to get x by itself. X equals 38 divided by negative 19. Oh, positive 19. Oh, excuse me. Can't believe I almost did that. 21x minus 2x is a positive 19. Full of mistakes here. But I caught it before the end, so we're fine. 38 divided by 19 is a positive 2. All right. Almost there. Hopefully no more mistakes. But I've been catching them, so give me a like for that. All right, x equals 2. We got to plug that in and solve for y. So let's go to the second equation. I think that looks easier. Negative 2 and for x, or positive 2 and for x, we have 3y equals minus 19. 2 times a negative 2 is a negative 4 plus 3y equals negative 19. Add 4 to both sides. 3y equals negative 19 plus 4 goes reverse, so we got, was it 15? A negative 15 here. Divide both sides by 3, and y is by itself, and negative 15 divided by 3 is a negative 5. So we have our two values here. X is 2, y is negative 5. We can write it as a point, and there we have it. 2 comma negative 5 is our solution. We're given this system. 16x minus 10y equals 10. Negative 8x minus 6y equals 6, and we have to solve that by elimination. So what am I going to do? Well, my goal is to try to eliminate one of our variables if we can by adding, but right now we can't, so we have to adapt this. A lot of teachers will only have students talk about multiplying by a whole number or an integer. Well, right, this first one here, if I multiply it by a 1/2, the 16 becomes an 8, and we'll eliminate the x variable. But I double check that all of these numbers can evenly be multiplied by 1/2 and still get an integer. So, since that works, I'm choosing 1/2. 1/2 times 16x is an 8x. 1/2 times a minus 10y is a minus 5y. 1/2 times 10 is 5. Bring the second equation over. Minus 8x minus 6y equals 6. Add the two equations together and see what happens. 8x plus a negative 8x cancels out. Minus 5y plus a negative 6y is a negative 11y, and 5 plus 6, positive 11. Divide both sides by a negative 11, and y is by itself to be a negative 1. We then take that information and we need to plug it into one of our equations, which we think is easier. Let's pick the second equation here. Negative 8x here minus 6 times a negative 1 equals a positive 6. Minus 6 times a minus 1 is a positive 6, so 8x plus 6 equals 6. Subtract 6 to both sides. Negative 8x by itself, and that equals 6 minus 6, which is 0. Be careful. Divide both sides by minus 8, and x equals 0 divided by negative 8, which is still 0. So our coordinate point is 0, negative 1, and that is our final answer. We're given this problem. 8x plus 14y equals 4. Negative 6x minus 7y equals a negative 10. I noticed that 14y minus 7y. 7 times 2 is 14. Well, if I multiply the whole second equation now by 2, I know this negative 7y will turn to a negative 14y, and we'll cancel out the y's. So that's our goal. Top equation comes over, 8x plus 14y equals 4. Second equation, multiply that 2 across. 2 times negative 6x is a minus 12x. 2 times a minus 7y is a minus 14y. 2 times a negative 10, negative 20. Okay? All right, so now we're going to add these two equations together. That's a 20. 8x plus a negative 12x is a negative 4x. 14y's cancel here, right? 14y plus a negative 14y cancels. And 4 plus a negative 20 is a negative 16. Divide both sides by a negative 4. And x equals negative 16 divided by a negative 4, which is a positive 4 right there. All right, we had x equals 4 here. Now we want to get y, or solve for y. So we take this equation and we need this value 4 and plug it into one of our equations. Which one we think might be easier? kind of a toss-up for me, so let's just go with the second equation. Negative 6x, instead of x, I'm putting a 4. Minus 7y equals a negative 10. Negative 6 times 4, negative 24, minus 7y equals a negative 10 here. Okay? Add 24 to both sides. And negative 7y is right here, equals negative 10 plus 24, which is a positive 14. Divide both sides by negative 7. And we're left with y by itself. 14 divided by negative 7 is a negative 2. So we have our values: x is 4, y is negative 2, and there is our final answer. We're given this problem: minus 4x minus 15y equals a negative 17, and minus x plus 5y equals a negative 13. Well, I notice here we have negative 15y and a positive 5y. So 5 I know times 3 is 15, and then we can add the two equations and eliminate y. So I'm going to take my whole second equation and multiply it by 3. The top equation stays the same: minus 4x minus 15y equals a negative 17. Second equation, multiply 3 to all parts, don't forget them. 3 times a negative x minus 3x. 3 times 5y is a 15y here. 3 times a negative 13 is a negative 39. Alright, we add our two equations together and see what happens. Negative 4x plus a negative 3x is minus 7x here. Negative 15y plus a positive 15y is a 0y. Negative 17 plus a negative 39 is a negative 56. We're now just solving for x still. Divide both sides by negative 7. X equals a negative 56 divided by negative 7 is a positive 8. We take that information and plug it into one of our other equations and solve for y. I like the second equation because it looks simpler. Negative instead of x, put the 8 in. Plus 5y equals a negative 13. Well, minus 8, let's add an 8 to both sides here. And we're left with 5y equals here, well, negative 13 plus 8 is a negative 5. Divide both sides by 5. Y is by itself. Negative 5 divided by 5 is a negative 1. So our x value is 8, y value is negative 1, and there we have our final answer: 8, negative 1. We're going to solve the system by elimination, and we're given negative x minus 7y equals 14. Negative 4x minus 14y equals 28. I see the 7 and 14, and I can multiply 7 by 2 to get 14, so there's my goal. If I multiply it by a negative 2, though, I'll get a positive 14y here, which then eliminates the y variable. So let's multiply the whole top equation by negative 2. Negative 2 times negative x is a positive 2x. Negative 2 times a negative 7 is a positive 14y. Negative 2 times 14 is a negative 28. Second equation just comes over. Minus 4x minus 14y equals 28. We now add the two equations here. 2x plus a negative 4x is a minus 2x here. 14y plus a negative 14y eliminates the y. That was the goal. Negative 28 plus a 28, ooh, be careful, also a 0. Divide both sides by a negative 2. And don't get tricked here. X is equal to 0 divided by negative 2, which is 0. Okay? Make sure you're dividing by negative 2 there. We take that fact and plug it into our second equation, in one of our equations, and solve for y. We can choose which one we want, and let's just choose the first one. I think it's easier. Negative, or 0 in for x, so we have a negative up front, minus 7y equals 14. Well, we can't really have a negative 0, so it's just 0. Don't need it. We have negative 7y equals 14. Divide both sides by negative 7. That's the opposite of multiplication. Y is by itself, and 14 divided by negative 7 is a negative 2. And so now we're left with x is 0, y is negative 2. Let's write that as a coordinate point. And there is our final answer, 0, negative 2. We're given this problem: negative 7x minus 8y equals 9, and minus 4x plus 9y equals a negative 12. Well, my goal is to try to find some variables that eliminate but here there's nothing that directly does. So we're going to have to multiply each one of these equations actually by a number. So my goal is I'm going to eliminate the x. To do that, I'm going to multiply the second equation by a positive 7, and the top equation by a negative 4. We want to make sure we have at least one of these equations, negative one's positive, right, of the x values, so when we add them, they eliminate. So what does this look like? Let's go to the top. Negative 4 times negative 7x is a positive 28x. Negative 4 times a negative 8y is a positive 32y. And negative 4 times 9 is a negative 36. Keep going. Second equation. 7 times a negative 4x is a negative 28x. Looking good. 7 times a 9y is a 63y. And 7 times a negative 22 is a negative 154. We add the two equations together. The x's get eliminated, and we're left with 32y plus 63y, which is 95y. Negative 36 plus a negative 154, a negative 190. Divide both sides by 95, and we get the humble answer of y equals a negative 2. But we're not done. We need to take that negative 2 and plug it into one of our equations and solve for x. Let's choose the second one. Minus 4x plus 9 times a negative 2 equals a negative 22. All right. Well, negative 4x here. 9 times a negative 2 is a minus 18 equals a negative 22. Adding 18 to both sides. Bring down the minus 4x. And negative 22 plus 18 is a negative 4. Divide both sides by a negative 4. And we're left with x by itself, and negative 4 divided by negative 4, positive 1. So our point here is 1 comma negative 2, and there we have our final answer. We're given this problem. 5x plus 4y equals negative 30. 3x minus 9y equals a negative 18. We gotta solve this. Well, I can't just add the two equations right now. Nothing gets eliminated. So what I need to do is multiply the numerator, or the top equation and bottom equation, by something. Let's go to try to eliminate the x value first. I'm going to take the top equation and multiply it by 3. The bottom equation, multiply it by negative 5. Negative 5 times 3, negative 15. 3 times 5 is 15. The x's will eliminate. So let's do that. 3 times 5x is 15x. 3 times 4y is a 12y. And 3 times the negative 30 is a negative 90. Second equation, negative 5 times 3x is a negative 15x. Negative 5 times a negative 9y is a positive 45y. Negative 5 times a negative 18 is a positive 90. We add the two equations here. The x's eliminate. That was the goal. 12y plus 45y is a 57y. Negative 90 plus 90 is just 0. Be careful here. We still have to divide by 57 to both sides, but y is just 0. We take that information and we plug it into one of our equations and solve for x. Let's choose the second one. 3x minus 9 times 0 equals negative 18. 9 times 0 is just 0, so we're left with 3x equals a negative 18. All right, divide both sides by 3, and x equals, well, negative 18 divided by 3 is a negative 6. So our final answer as a point, negative 6 comma 0, and there we have it. We're given this problem. Negative 4x minus 2y equals 14. Negative 10x plus 7y equals negative 25. And we want to solve this system. Well, I can't just add these two equations right now. Nothing's going to get eliminated. So we need to multiply the top equation and bottom equation by something to eliminate a variable. Let's go with the x's here. If I take the top equation and multiply it by a negative 10, and the bottom equation by a positive 4, the bottom becomes a negative 40x, the top becomes a positive 40x, and we will eliminate those x's. So let's do that. Top equation by negative 10. Negative 10 times negative 4x is a positive 40x. Negative 10 times a negative 2y is a positive 20y. Negative 10 times 14 is a negative 140. Don't forget to keep bringing the negative over. 4 times negative 10x is a negative 40x. 4 times 7y is a 28y. And 4 times a negative 25 is a negative 100. Keep it 100, everybody. All right, let's add the two equations together. 40x plus negative 40x is just 0. 20y plus 28y is 48y. And negative 140 plus a negative 100 is a negative 240. Divide both sides by 48 here to get y completely by itself. And y is, well, negative 240 divided by 48 is a negative 5. We got our y value, we need to find our x value. So we got to choose an equation and plug y equals negative 5 in for x. Let's choose the second equation. Negative 10x plus 7 times negative 5 for the y value equals negative 25. Now we're solving for x here. Negative 10x, well, 7 times negative 5 is a minus 35 equals a minus 25. We add 35 to both sides. Let's keep on this journey to get x by itself. Negative 10x is left here. 35's cancel. And negative 25 plus 35 is a positive 10. Divide both sides by negative 10, and good old x is by itself to be a negative 1. We got our x value, we got our y value. Let's write that as a coordinate point. Negative 1 comma negative 5. Just double checking there. And there we have our final answer. Negative 1 comma negative 5. We're given this problem. 3x minus 2y equals 2 and 5x minus 5y equals 10. We're solving by elimination. I cannot just add these two equations together because nothing's really going to eliminate. So I need to multiply it by a factor. Let's make our goal here to eliminate the y values. 5 times 2 is 10. 2 times 5 is 10. So we do some adaptation there. We can eliminate. Let's take our numerator and multiply it by a positive 5. Our denominator by negative 2 here. And let's see what happens. Notice why I did the negative 2. I want this to be a positive 10y here, so then we can add it easily. 5 times 3x, 15x. 5 times a negative 2y minus 10y here. And 5 times 2 is 10. Second equation, negative 2 times 5x is a negative 10x. And negative 2 times a negative 5y is a positive 10y. Negative 2 times a 10 is a negative 20. Make sure I'm keeping this 100 here. All right, add the equations together. 15x plus a negative 10x is a 5x. The negative 10y plus 10y, eliminate. That was our goal. 10 plus a negative 20 is a negative 10. Divide both sides by 5 here. And x is by itself. That was the goal. Negative 2. Negative 10 divided by 5 is a negative 2. All right. We take that information and we plug it into one of our equations to solve for y. Which one do we think is easier? I think the top one. 3 times a negative 2 instead of x minus 2y equals 2. Let's solve for y. 3 times negative 2, negative 6 minus 2y equals 2. We add a 6 to both sides. Negative 2y equals 2 plus 6 right there. Make sure I'm on the right page here. 2 plus 6 is 8. Lost my place for a second here. Just wondering why. No, whatever. Doesn't matter. Divide by negative 2 to both sides. You just want the answer. And we got y by itself. 8 divided by negative 2 is a negative 4. So y is negative 4 here. X is a negative 2. Let's write that as a coordinate point. Negative 2, comma, negative 4. And there we have it. We have our final answer. We're given this problem. 5x plus 4y equals negative 14. 3x plus 6y equals 6. And we're solving by elimination. Well, right now, I cannot add these two equations together. If I did, nothing would eliminate. Be pointless. So we have to multiply both of them by some factor. Let's try to eliminate the x. If If I multiply the top by a 3 and the bottom by a -5, -5 times 3 is -15. 3 times 5 is 15. The x's will eliminate when we add them. So now let's do that to all parts then. 3 times 5x is 15x here. 3 times 4y, well, that's 12y. 3 times a -14 is a -42. -5 now to the second equation. -5 times 3x is a -15x. -5 times 6y, -30y. And -5 times 6 is a -30. We add the two equations together. Our goal is to get the x's to eliminate, and they do. 15x plus a -15x is just 0. 12y plus a -30y is a -18y. And -42 plus a -30 is a -72. Divide both sides by a -18. And what do we get? Well, y by itself, -72 divided by -18. Negative divided by negative is a positive. Y is 4. We take that information and we need to plug that back into one of our equations and solve for x here. I think the second one's the easiest one. So, 3x here plus 6. Instead of y, we put a 4. Equals 6. 6 times 4 is a 24. And we have 3x right there. All right, so now we got to get, again, x by itself. Subtract 24 to both sides. 3x here, 24's cancel out. 6 minus 24 is a -18. Divided both sides by 3. X by itself, -18 divided by 3 is a -6. So we have our x value, our y value. Let's write it as a coordinate point, people. -6, 4, and that is our final answer. We're given this problem, 2x plus 8y equals 6, -5x minus 20y equals a -15. And we're solving for x here. Well, what do I want to do? Elimination here asks us to add these equations together to eliminate a variable. We can't do that right away. So we have to multiply the top equation and bottom equation by some number. Well, let's go try to eliminate the x value here. If we multiply the top by 5, we get 10x here. Bottom one by 2, we get -10x. Add them together, they eliminate. There's the goal. So top by 5, bottom by 2. All right, so let's do that. 5 times 2x is a 10x here. 5 times 8y, make sure we go for everything, is 40y. And 5 times 6 is 30. Second equation, 2 times -5 is a -10x. 2 times -20 is a minus 40y, or 20y, right? And 2 times a -15 is a minus 30, right there. We add the two equations together. 10x plus a -10x is 0. That was our goal from the beginning. Great. Net plus 40y plus a -40y is 0 as well. 30 plus a -30 is also a 0. So 0 equals 0. It's a true statement, but we have no variables. All of our variables were eliminated. So what does that mean? That means we actually have an infinite number of solutions. So that means there's infinitely many number of solutions for x and y that we can plug in, and this would be correct. Okay, so we have an infinite number of them. That is our final answer. We're given this problem here. Minus 14 equals -20y minus 7x. 10y plus 4 equals 2x, and we need to solve this by elimination. Well, first we need to rearrange this to have the x and y's on one side and our numbers on the other. First equation's fine, so we can leave it as such. Minus 14 equals a minus 20y minus 7x. Here, let's subtract the 10y to both sides, so we're left with 4 left over. Subtract the 10y right there, and then just a 2x left over. All right, so now we got to eliminate. Well, we can't just add these two equations. Nothing that we add together really will eliminate a variable. So what variable should we try to eliminate? Well, I'm going to try to eliminate the y's. The second equation, I can see if I multiply it by just a -2, we'll have a positive 20y here, and the y's will cancel. So let's take the second equation and multiply it by -2. Top equation, again, stays the same. Minus 14 equals a -20y minus 7x. The second equation, -2 times 4 is a -8. Make sure you multiply it to all parts. -2 times the -10y is a positive 20y. -2 times 2x is a minus 4x. All right, so now we're going to add our two equations here, and let's see if the y's eliminate. -14 plus a -8 is a -22. -20y plus a 20y is, well, 0. That was the goal, 0y. They're eliminated. -7x minus 4x is a -11x. All right, we want to get x by itself. Divide both sides by -11, and x by itself here, -22 divided by -11. Negative divided by negative is a positive, and so we have a positive 2 here. 22 divided by 11 is 2. So x is 2, but we're not done. We need to pick an equation and solve for y. So it doesn't really matter which equation we pick, but I like to pick the easier one, and I think it's the second one right here. Okay, so we have 10y plus 4 equals 2. Plug in that 2 for x. All right, 10y plus 4 equals 2 times 2, 4. Subtract a 4 to both sides, and 10y is by itself here. And 4 minus 4 is good old 0. Divide both sides by 10. That's opposite of multiplication. 0 divided by 10 is 0. So y is 0 here. So combine the two parts. Our final answer is 2, 0. And that is our coordinate point. We're given this problem, 3 plus 2x minus y equals 0, and minus 3 minus 7y equals 10x. We need to solve this by elimination. Well, first, they're not aligned right. So let's get all of our x and y values to the left, our numbers just to the right, the constants, okay? So the top equation, we just subtract a 3 to both sides, and we're left with 2x minus y equals a minus 3. All right. Not too bad. The second equation, we got it in two parts. We're going to add a 3 to both sides, but then subtract the 10x and put it to the left. So subtract 10x to both sides, minus 10x there. Keep the minus 7y on the left-hand side, but we're going to add a 3 to both sides. So now we have a positive 3 on the right-hand side. So now I'm looking at my equations, and I'm thinking, all right, can I add them together? Can I add them together to eliminate a variable? And no, I can't. So what do I need to do? I need to multiply the top or the bottom by some factor, see what eliminates. I'm looking at the x's. 2 times 5 is 10. That will eliminate with a minus 10x, right? So I'm going to take the top equation and multiply it all by 5. 5 times 2x is 10x. 5 times a minus y is a minus 5y. 5 times a negative 3 is a negative 15. Second equation just goes on over, minus 10x minus 7y equals a positive 3 right there. All right, let's add the equations together. 10x plus a negative 10x, that was the goal. They're eliminated, it's 0. Negative 5y plus a negative 7y is a negative 12y. Negative 15 plus 3 is a negative 12. Oh, this is getting easy and nice. I like it. Divide both sides by a negative 12. And y equals negative 12 divided by a negative 12 is a positive 1. So where do we go from here? We got our y value. We got to find its partner, the x. So we take an equation, one of the equations, and we plug y and 1 in for y and solve for x. Find an equation that's easier from the original ones. I think it's the second one. So minus 3 minus 7. Instead of y, I'm putting a 1 in. Equals 10x. So now I'm solving for x again. Well, so not too bad actually. Minus 3 minus 7 times 1 is just 7. We have 10x here. Minus 3 minus 7, negative 10. Ooh, this is looking familiar. We want to get x again by itself. Divide both sides by 10. And we have x equals negative 10 divided by positive 10 is a negative 1. So we have our x and y value. Let's write that as a coordinate point, negative 1, 1, and that is our final answer. I hope you learned something here about solving systems of equations by elimination. If you did, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So, as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.